Since the inception of universe, it's full of surprise and mysteries. One of the mysteries is, do aliens exist? Is there intelligent life beyond our planet? We'll explore the fascinating evidence and research on this topic, so be sure to stick around until the end. Chapter 1: The Search for Life. Our quest to find extraterrestrial life has taken us to the far reaches of the universe. Scientists have been actively searching for signs of life on other planets and moons. One of the most exciting missions is the search for microbial life on Mars, thanks to rovers like Curiosity and Perseverance. Mars isn't the only target, though. There are several other promising candidates in our solar system, like Europa and Enceladus, where the potential for life in subsurface oceans is being investigated. Chapter 2: UFO Sightings and Extraterrestrial Encounters. Over the years, there have been countless reports of strange aerial phenomena. Some believe these could be evidence of alien visitations. In recent years, the US government has even declassified and released several videos captured by military pilots, showing unexplained aerial objects with extraordinary capabilities. Project Blue Book. Project Blue Book was a systematic, government-sponsored study of UFOs conducted by the United States Air Force. The project operated from 1952 to 1969, and this project was led by Dr. J. Allen Hynek, an astrophysicist and astronomer. Its primary objective of Project Blue Book was to scientifically investigate and assess UFO reports to determine if they posed any threat to national security. Project Blue Book collected and examined thousands of UFO reports from the public and military personnel. Investigations typically involved interviewing witnesses, gathering photographic or physical evidence, and applying scientific and technical analysis. Conclusions and classification. After each investigation, UFO reports were classified into one of three categories. Identified, objects were readily explainable as known phenomena, example, weather balloons, aircraft, astronomical events. Insufficient information, 2. The report lacked adequate data to make a determination. Unidentified, 3. The report could not be explained by known natural or human-made phenomena. Project Blue Book was officially terminated in 1969, with the US Air Force concluding that UFOs posed no national security threat, and that there was no evidence of extraterrestrial visitation. The closure of Project Blue Book did not end public interest in UFOs. Some UFO researchers and advocates believe that the US government continues to investigate UFOs. Chapter 3: The Drake Equation. The Drake Equation is a mathematical formula developed by Dr. Frank Drake in 1961 to estimate the number of technologically advanced extraterrestrial civilizations that might exist in our Milky Way galaxy. The equation is expressed as follows: n equals multiplication of r asterisk fp ne fl phi fc l. Here's what each term in the equation represents. N is the number of civilizations in our galaxy with which we might be able to communicate. This is the quantity we're trying to estimate. R asterisk is the rate of star formation in our galaxy. It's the number of new stars formed per year. Fp is the fraction of those stars that have planetary systems. Not all stars have planets orbiting them. Ne is the number of planets that could potentially support life in each planetary system. This term considers factors like the distance from the star and the planet's composition. Fl is the fraction of those planets that actually develop life. This factor accounts for the conditions on a planet that might allow life to emerge. Phi is the fraction of planets with life that develop intelligent life. This is a more specific subset of the previous factor, focusing on civilizations that are capable of transmitting signals or communication. Fc is the fraction of civilizations that develop technology capable of interstellar communication. This considers the technological and social factors that allow a civilization to send signals into space. L is the length of time a civilization actively communicates with other civilizations. This factor accounts for the duration a civilization exists and communicates before self-destructing or ceasing to transmit signals. Let's find out the possibility using the following estimates for each term. R asterisk, rate of star formation 10 new stars per year. Fp, fraction of stars with planetary systems 0.5, or 50% of stars. Ne, number of planets that could potentially support life 2 planets per star with a planetary system. FL, fraction of planets that develop life 0.2, or 20%. Phi, fraction of planets with life that develop intelligent life 0.01, or 1%. FC, fraction of civilizations that develop technology for communication 0.1, or 10%. L, length of time a civilization communicates 100 years. Now, we can calculate n. After substituting the values we got, n equals 0.0001 civilizations. In this hypothetical example, we estimate that there might be 0.0001, or 1 in 10,000 of a civilization in our galaxy with which we could communicate. This means that there could be minimal chance of finding intelligent extraterrestrial life based on these estimates. The problem with Drake's equation that he considered extraterrestrial life able to communicate like us. But he didn't consider life form like microbial life, which is life itself, but their way of communication is different, or a very intelligent life which we haven't achieved that technological advancement yet. Chapter 4, the Fermi Paradox. The Fermi Paradox is a perplexing question that arises from the apparent contradiction between the high probability of the existence of extraterrestrial civilizations in the universe and the lack of evidence or contact with such civilizations. The implications of the Fermi paradox are profound and have led to various hypotheses and theories. Here are some of the key implications and associated theories. 1. Great filter hypothesis. This theory suggests that there must be one or more highly improbable steps in the development of intelligent civilizations that make it extremely rare for such civilizations to emerge. The great filter could be behind us, example, the emergence of life is rare, or it could lie ahead, example, self-destruction is common for advanced civilizations. 2. Silent universe hypothesis. This idea proposes that intelligent civilizations are out there, but for some reason, they are intentionally avoiding communication with other civilizations, or they communicate in ways we cannot yet detect. 3. Rare Earth hypothesis. This hypothesis suggests that conditions for life, especially complex and intelligent life, are exceedingly rare in the universe. Earth might be an exceptional case, and other life-supporting planets are scarce. 4. Zoo hypothesis. According to this theory, advanced extraterrestrial civilizations are aware of us but have chosen to observe or study us without revealing their presence. They might be operating under a prime directive not to interfere with less advanced civilizations. 5. Self-destruction hypothesis. Some theories posit that advanced civilizations tend to self-destruct through technological, ecological, or social means before they can become interstellar civilizations. This could explain why we haven't encountered them. 6. Technological limitations. It's possible that advanced civilizations exist, but they are simply too far away, and the limitations of physics and technology prevent us from detecting their signals or traveling to meet them. 7. Early civilization. Earth might be one of the first civilizations to arise in the Milky Way, and others will emerge in the future. This could explain the lack of contact with extraterrestrial civilizations. 8. Simulation hypothesis. Some suggest that we might be living in a simulation, created by an advanced civilization, which could explain our lack of contact with other extraterrestrial beings. The Fermi paradox underscores the tantalizing and unanswered question of whether we are alone in the universe. Finding an answer to the paradox could reveal important insights about the nature of life in the cosmos and the future of humanity. Chapter 5, The Wow Signal. August 15, 1977, the Big Ear telescope captured a signal that lasted exactly 72 seconds. What's fascinating is that it was exceptionally strong, 30 times greater than background noise, sparking speculation about its possible extraterrestrial origin. The signal was detected at a frequency of approximately 1420 MHz, which is within the microwave range of the electromagnetic spectrum. This frequency is significant because it is close to the naturally occurring radiation emitted by hydrogen, the most abundant element in the universe. One of the hallmarks of a credible extraterrestrial signal is that it should be repeatable. Unfortunately, despite multiple attempts, the WOW signal was never detected again. Source uncertainty. The signal source could not be pinpointed because the Big Ear telescope had no tracking capabilities. As a result, it could have been from a transient or moving object, such as an Earth-based satellite. Some scientists have suggested that the signal could have been produced by natural phenomena like a passing comet, or human-made interference like a terrestrial source of radio waves. Conclusion. So, do aliens exist? While we don't have definitive proof yet, the evidence and research in the field of astrobiology, UFO sightings, and the search for techno-signatures continue to intrigue and inspire us. Whether we find microbial life on Mars or detect a signal from the cosmos, the quest to answer this age-old question remains one of humanity's greatest adventures. If you enjoyed this exploration of the existence of aliens, don't forget to like, subscribe, and hit that notification bell for more mind-expanding content. And as always, keep looking up at the stars, for there's always something fascinating out there in the universe. Until next time, stay curious and keep exploring.